OpenAI, Microsoft, Google, Meta, they're all racing toward the same goal: building the most powerful artificial intelligence systems in history. To get there, they're buying hundreds of thousands of NVIDIA chips and investing hundreds of billions of dollars into AI infrastructure. But behind this technological revolution lies a problem that almost nobody is talking about. The AI industry isn't running out of chips, it's running out of power. Around the world, electricity demand is growing faster than new energy infrastructure can be built. Power grids are being pushed to their limits, and some of the world's biggest technology companies are making a decision that would have sounded impossible just a few years ago. They're turning to nuclear power, not to light up cities, but to power artificial intelligence. How did a software revolution become an energy crisis? Let's find out. Every breakthrough in artificial intelligence begins with one essential ingredient: computing power. And today, no company sits closer to the center of that revolution than NVIDIA. Its AI processors are engineering marvels, capable of performing trillions of calculations every second. But that incredible performance comes at a price. Modern AI accelerators can consume nearly 1 kilowatt of power each under heavy workloads. Pack dozens of them into a single server rack, and that rack can demand well over 100 kilowatts of continuous power. That's more electricity than many homes use combined. Now imagine tens of thousands of these GPUs running 24 hours a day inside a single hyperscale data center, training frontier AI models for weeks or even months. These facilities don't just need electricity, they need continuous, uninterrupted baseload power. Even a brief power interruption can halt an expensive training run, wasting weeks of computation and potentially millions of dollars. The challenge is no longer building faster chips. It's finding enough electricity to keep them running. Just a few years ago, the biggest challenge facing the AI industry was getting enough advanced chips. Today, that challenge has changed. The new bottleneck is power. Across the world, electricity demand from AI data centers is rising at an extraordinary pace. In places like Northern Virginia, home to the world's largest concentration of data centers, along with Ireland and Frankfurt, power grids are being pushed closer to their limits. Utility companies are now receiving requests for electricity levels once associated with entire towns or even small cities. But these requests are coming from a single AI campus. Building new transmission lines, substations, and power plants can take years. AI infrastructure is expanding much faster. The result is a growing gap between the computing power the world wants and the electricity it can actually deliver. In many regions, the next generation of artificial intelligence isn't being limited by silicon anymore. It's being limited by the electrical grid, rather than waiting for the electrical grid to catch up. Some of the world's biggest technology companies are taking a different approach. They're investing in energy itself. Microsoft captured global attention after announcing an agreement to support the restart of a dormant reactor unit at 3 Mile Island. The goal: helping secure reliable electricity for the next generation of AI infrastructure. Microsoft isn't alone. Amazon and Google have also announced major investments in nuclear technologies. From small modular reactors to long-term clean energy partnerships, big tech is preparing for a future where electricity may become its most valuable resource. Why nuclear? Because AI data centers don't just need clean energy, they need reliable energy. 24 hours a day, 7 days a week, rain or shine. Nuclear power is one of the few carbon-free energy sources capable of delivering that kind of continuous, baseload electricity. For companies running enormous AI data centers, reliability has become just as important as the chips inside the servers. The next phase of the AI race won't be decided by smarter algorithms alone. It will also be decided by who can secure enough energy to power them. When the AI revolution began, most people believed the biggest challenge would be building smarter software. But the story took an unexpected turn. One of the greatest obstacles isn't intelligence, it's electricity. The future of artificial intelligence won't be determined only by who builds the smartest models. It will also be shaped by who can secure the energy to power them. Because the next trillion-dollar race won't be fought over software alone. It will be fought over energy. And as AI continues to reshape the global economy, the companies that control computing and the companies that generate power may become more connected than ever before. If you enjoyed this deep dive into the hidden economics behind artificial intelligence, subscribe to Algo Economics and click the video on your screen to explore the next critical piece of the AI supply chain.